IoTs or sensors, or even from the web sites, social media sentiment analysis and all that. Basically, you might need those kind of data. So you have to ingest those kind of things also into big data. And the fourth one, if you look at it, it's more about to help data scientists. They want to do a lot of experiments and data exploration in terms of carrying out some of the machine learning and data mining, data exploration, these kind of things. So where some of the use cases basically to give them an analytics sandbox, and once the experiment is successful, they may want to move on to the production. So you need to support those requirements. And the final one, if you look at, they don't want to basically kind of throw away the existing investments in the data warehouse, better to leverage and also have a big data lake in parallel. It's like having a best of both worlds, where you want to basically still continue with some of the BI reports on the data warehouse and all the newer kind of analytics that you want to do it on the big data lake. So of course, from the architectural standpoint of view, you might need some kind of federation layer, a data virtualization layer, those kind of things still will be there. But more or less, these are the scenarios that we have seen. And imagine, all these, as I said, they go hand in hand. So they require a lot of common functionality. You need to have the ingestion. If you look at most of these scenarios require a data ingestion framework. And you need to take care of the operational metadata. So how basically the jobs are running and how you can actually leverage some of the job configurations and all that. And also if you look at other part is the preparation part. Most of the cases, as you have to not only ingest the data, but also do a lot of data quality to get into the kind of curated zone. So all these basically requires a lot of effort. So from that standpoint, just imagine how basically a lot of effort that you need to put on the 4 aspects. The 4 aspects could be the development effort, where you need to build the framework initially, and also you need to validate all that using whatever the testing frameworks that you have. And then you have to take care of the deployment part. So this is again a lot of manual effort that goes in deployment. So how do you take care of these kind of things? And finally, if you look at once the big data solution is operationalized, how do you basically monitor that? So it's not basically once you're done with the implementation, basically things are not done, right? Basically you need to also take care of the monitoring part of it. So how do you basically take care of that part? So all these things require a lot of effort in terms of building those things. Let me move on to the next slide. So if you take one step back and see, assume that you got to go ahead from the business sponsor and you are ready with your Hadoop investment, the big data investment, but a lot of challenges, as I said. So primarily that if you look at the implementation related, as I said, unless you have a framework, you will end up actually spending a lot of 5 to 6 months in just building the required framework for the data ingestion part, or even from the data quality part that I was talking about on the deployment aspects. So testing. So how do you basically expedite that process is the one question basically that whenever the team starts, that will be there in their mind. And also inherent complexity, if you look at, it's not just about, volume is given, right? You end up doing a lot of processing of the high volume data. That's a given in big data world. But also you need to take care of a lot of variety of data that is coming. It could be web clickstream data, or it could be IoT data, the sensor data, or it could be even the unstructured data. So you need to process all these different varieties of data. So there also you have a lot of challenge. How to basically address those kinds. And as I said, once you are done with your initial implementation, then the actual tough part starts, the operational part of it. So how do you take care of the version controls? And platforms are evolving. How do you basically go away from the vendor lock-in? So these are some of the challenges always you will get into. And I think the biggest challenge, all of us, we know that the scarcity of the skill. So the expectation is so large that you expect the team to have complete end-to-end knowledge, starting from the data ingestion to the processing part. Many processes that you expect that. So you expect the team to be good at the MapReduce, the pig scripting, even the Spark, or even from the R language, whatever. Various aspects that you expect the team to basically kind of skilled at and try to address these parts. That's very difficult. in reality, it is very challenging to get those kind of things. And as you see that plethora of technologies, so you can't even expect that the teams basically to get into one particular technology or the couple of technology. That takes months to basically for them to get into a kind of very productive environment. I think in the other session, a lot of talk has happened on the business-related challenges. I think most of us know. So assume that where you have a lot of data, but how do you basically go about that? What is the right size for your use case that you have taken, and what is the context that you want to do it? So these are some of the challenges before you even start the big data initiative. And also, after all heavy lifting is done, really business take that up, or basically there will be so the challenge is basically how quickly you can actually show that insight on the whatever the kind of ROI that you're looking at in a quick way. So that warrants that. So from that perspective, you can't basically go in a manual way of building everything and taking, say, about more than 6 months or 9 months to give some kind of a big data solution there. So you have to basically expedite the whole process and try to give it in probably in few weeks or couple of months. So that is the expectation if you look at. So what basically Wipro has done is, so we basically came up with a big data open source big data framework. So this is basically available on the GitHub, and I encourage all of you to basically look at that and download it and start accessing it and also contribute to that. So as we said, this is completely a community-based framework, and some of the challenges that we have seen in the earlier slide are taken care of from that sense. So there is a framework that is readily available. 50% of the work is already done. You start, basically pick up that framework and start building your business logic on top of it. So what are taken care of? The ingestion aspect is taken care of. The operational metadata management part is taken care of. Data quality part is taken care of. Deployment part is taken care of. Some of these things, as you have seen, so those are the basically time-consuming activities in any big data implementation. So those things are taken care of. The framework is available. So pick up and start building your logic on top of it. So that was the main intention behind this particular the framework. And we have another flagship product called data discovery platform. So that's completely a pre-built cloud-based and on-prem also. Basically, it's based on on-premise also, where you have all the pre-built customer use cases, whether it be a particular telecom domain or a healthcare domain or any other industry. All those the typical use cases are already implemented, and you have an end-to-end process available there. So you can actually ingest the data into that, and also you can do all the wrangling and start doing the data discovery part, and finally visualization. So everything is available in that. So for that particular DDP product, so BDRE is the main behind the scenes. It fuels the data ingestion part. So that way basically it is actually a very complementary product from that sense also. So tomorrow you can have your own different data discovery platform. Still BDRE can be used. You can actually always use this as a upstream activity for you to actually do the data consumption part. Now also this is in the last Hadoop Summit. This is the best community choice award. Basically that is what in the Hadoop Summit we got. And if you look at some of the, if you want to look at some closer view on how basically this is done, as I said, when you have an Hadoop system and when you want to build the data ingestion part, so the framework is available, and also this gives you a unified integration environment where not only just ingestion part and also processing this into the Hive tables or the next processing aspects. Those things are also basically available. And so if you look at the life without a BDRE and the BDRE, so you'll end up actually spending a lot of time in building these the common frameworks which are the minimum hygiene probably that you need to start any big data initiative. So that is already available. You can actually pick up that and you can just build the logic. So this is a pluggable architecture, and so pretty much you can actually want to extend this to any of your application development. Rapidly you can do that, and as I already said, this is community driven, so you can go ahead and basically contribute to that, whatever the use cases that you want to work on, you can work and also contribute to that. So also this is distribution compatible. What I mean by that is, so it works with Hortonworks and Cloudera and even your traditional Apache distribution. So you can leverage all those investments. So still you get the benefit of this BDRE, where you can take care of the frameworks that require to build the minimum plumbing that is required for big data solution. So that is already there. So as I said, probably half work is done. It is very easy to jumpstart the big data journey without even worrying about how basically you want to take care of the minimum required hygiene that is mandatory for any of the big data solutions. So this is a quick feature snapshot. As I said, data ingestion is the one major part, and that is the the time-consuming aspect in many of the big data initiatives. And data quality is obviously the important hygiene that is required in most of the data-intensive projects. So that aspect is there. And operational metadata and lineage is going to be the key aspect in any of the big data initiatives, because unless you have a right metadata, how do you basically take care of many of the aspects? So the reusability aspect and controlling the complete jobs, everything is done through this metadata management. So you can actually automate the jobs, and deployment is a pain, as you know. I think you may be good at doing everything and big data solution is ready, but when it comes to the deployment, really you spend a lot of time in spending in how to deploy. So there actually it's almost like a one-click button where you can easily build the deployment scripts and move on. So everything is actually user interface based. You can actually configure. So I'll spend few minutes going one of each of these things to give more sense on what basically we're talking about, each of the features that we are talking about here. So from the ingestion point, as we said, there might be multiple ingestion patterns that you may have to build, right? I mean, as earlier we were looking at a couple of slides back, where how do you basically ingest the data from not only from the regular structured RDBMS, but also from your sensors and the network logs and all that. How do you basically do that? So that part is basically taken care of here, and you can actually ingest data from RDBMS, flat files, XMLs, pretty much anything that is JSON format. Those things you can actually build. Not only ingest that into the Hadoop, but also you can process to the next step where Hive tables and all that. So that's possible. So web crawling is possible. Probably you can actually, we have a few videos available on the GitHub, and if you can search on the BDRE, you will get those things. And if you look at, there are quick videos where you can tell you how probably in minutes you can actually start crawling a website. So you have to set some of the URLs, and you have to give the parameters, and you can start actually doing that. So coming to the near real-time or the real-time based ingestion. So the data might be on the network logs or from the websites or from the sensors, whatever. So how do you basically do that? So pretty much everything, it runs under the, behind the scenes, whatever supports with Flume, that is taken care of here. Flume plus Kafka combination, always you can take care of this part. So also, so in the ingestion, this is one of the main aspects, right? Whichever the file that is coming into your Hadoop system, you want to do a validation. So you can actually do that kind of validation quickly. So those kind of things are possible. And other one that I was mentioning about the post-ingestion semantic framework. So framework is available. Once you do the ingestion, how do you basically go to the next step? So you might be having a data warehouse where you want to build all the Hive scripts and all that. So that's pretty much possible. You can actually start doing that aspect also as the next step. So semantic framework is available there. Let me move on to the next one on the data quality part. So this is the required hygiene, right? And any of the projects that we see that. So we have the BDRE integrated with rule engine. So pretty much you can actually start building all your data quality logic, whether it be a business rule that you want to check or the data rule that you want to check. Those things always you can do that. So either during the ingestion or the post ingestion, you can always enforce these kind of data quality into this. So this is. And also you can look at some of the data profiling reports and see how the quality of the data and all that. So I think one of the important aspects I was mentioning earlier also, development is one big exercise, but also if you look at testing is another challenge. So especially when you have scarcity in actually testers, Hadoop testers and the big data testers, the challenge, right? I mean, skill part is one, but other, if you look at how do you generate the test data? So your solution itself is a big data. You are expecting billions of records, and the testing framework that you're going to build are manually, you can't imagine, right? With a manual effort, testing effort on a big data solution is actually, I mean, clueless. Unless you have a utility where you can generate millions of records and try to see that part, so that won't be successful. You're not confident of your solution. So exactly, there is a utility that you can actually generate those test data, millions of records, and try to see that part. Let me move on to the next one. So yeah, probably three aspects are covered here. So automation is one part. You can actually do, as I was mentioning, once the ingestion is done, depending on your target structure and the use case, you might have to do multiple steps, right? I mean, a lot of pipelines you'll build, and pipeline one should ingest data into the pipeline two and further. So how do you basically design all those dependencies? So that is another aspect. So that is a needed thing, right? So it basically gives you that a visual flow where you can always drag and drop and try to build that kind of a data pipeline dependency and all that. So SCD2 logic is also possible, where you can actually try to do that on the Hive. So pretty much behind the scenes, you can use a Hive, pig scripting, MapReduce programs, and pig programs, and finally also the Spark and other Python scripting as you need. So it is integrated with Apache security aspect, that the Kerberos, or even Sentry and Ranger. So as I was mentioning, this is an open pluggable architecture. If you want to basically extend, pick and choose some of the components, and you want to do that, always you can do that integration part. So this product is completely metadata driven. So you will look at not only the lineage part of a process and how to understand how things are happening. This is one aspect during the development, but also the other part is during the operations. You are deployed, and all your jobs are running on the cluster. Hundreds of jobs are running, or rather thousands of jobs are running, but you want to look at how basically the performance is happening there. So you will be able to, for example, if you have an SLA, that each job has to be completed within stipulated 10 minutes or 15 minutes or 30 minutes. So you will quickly identify, it will basically trigger you that, once you configure it will trigger you that these are the jobs which are basically not meeting the SLA. So it is an administrator, right? I mean, the developer part we have seen. Also, if you look at the role of administrator, his job basically to look at these jobs which are not meeting the SLAs. So administrator can always look at these jobs and try to identify, okay, these are the jobs which are not running, not meeting the SLAs, and how to go about it. Of course, the automatic tuning of the jobs and is probably a different area. Today, we don't have in that framework, but the direction it goes there. But having the knowledge that these are the jobs which are basically not meeting the SLA is needed. So that is available. So as I said, so depending on the use cases, some of the small use cases, you can absolutely without writing any single piece of code, with clicks, you can actually do that. Of course, I mean, you have to give some kind of configuration in parameters and all that, but almost like a zero coding, you'll be able to do that. And coming to the data exploration part, because that is also, once you complete the ingestion part and process the part and data is available on any analytics sandbox, or for that matter, whatever the repository that you have, how do you basically do the exploration? So this has an integration with Zeppelin kind of tools, where you can actually do that kind of a data discovery also. Let me move on to the next one. So as I was mentioning about the deployment, so this is another challenge, right? I mean, when you, in a Hadoop scenario where you might be having thousands of jobs running, how do you basically deploy that? So it again takes a lot of manual effort. So this particular framework that gives you that. So if you look at the diagram where, right, I mean, it's basically is listed down. Once the job is registered, all the jobs are available within the metadata. And various options, if you look at a single view, you'll be able to deploy it. You'll be able to look at whether it is meeting the SLA or not, how the jobs are running, and all that basically are possible here. So everything is pretty much available. And behind the scenes, it uses Woozy. And there is no hard dependency on the Woozy. If you want to go ahead with a different workflow administrator scheduler engine, you can always do that because everything is available in the metadata. Always you can use that, and you can actually quickly integrate with any of the other workflow management tools. So this is the typical deployment view, and what you need if you want to start with this framework, right? So you need an edge node where all of the UI aspects are installed basically. So the app server, everything. Probably it requires a lightweight Tomcat server, and it requires a database because all the configuration, the job registry, metadata, everything is stored in database. So today we have basically it requires either Oracle database, MySQL database, or Postgres. So all the configuration data that stores in this particular database. And the left side, if you look at all the application libraries, all basically are there. So in a scenario where you want to basically write, alert, because there is a job got failed. So quickly, basically that pushes into the MQ, and an administrator will be notified about the failure of the job. So those things are also possible. And reactive alerting, always you can look at hundreds of jobs that ran for the last 1 month or 2 months and look at how the performance. You might have anticipated this particular job to run for so and so minutes, but it is actually taking more time. So those things also you can, in parallel, you can analyze. Let me move on to the next slide. Yeah, some of the this particular BDRE product helped some of our customers basically in some of the scenarios, right? If you look at, for one of the customers where they had customer data distributed across multiple regions. So they wanted to basically consolidate all the data, multi-million customer records into a single repository. And this is actually coming from 65 regions. But this particular use case required for them to, say, get this job done in 4.5 months. Because there is a requirement from the compliance perspective. They wanted to understand who are the various customers and all that. So it warranted basically the whole effort to be completed in 4.5 months. Imagine without a framework, right? It is very difficult to basically, if you want to build everything from the scratch, probably takes more than 6 months, or in some cases probably 9 months. So where exactly BDRE helped that particular customer? So we could actually complete everything in 4.5 months in the stipulated time. So that is almost like 40% reduction in what was originally anticipated to complete that particular exercise. So that's the one of the scenarios where for other customer where they had to join almost like 1,000 terabytes of data with another 10 terabytes of data. So imagine that scenario in a data warehousing, it is almost like impossible. So exactly here, so we basically, this particular BDR helped in optimizing all those high formats, and we tried to basically complete the whole thing. So there was some stipulated SLA. We met actually almost like reducing the effort by 50%. That is more from the SLA window perspective. In other cases, also data migration from a 1,000 node cluster to another probably 4 clusters. These from they want to distribute their domain data or the other data into 4 clusters. So imagine this, if you want to do it, probably it will take a couple of months or 3-4 months. So we could actually do it in about a week, because everything is available. We configured everything that is available in the metadata. It's more about that. Even the first use case also. So everything is metadata driven. I start with 5 regions, basically in the first scenario, 65 regions that I was talking about. So how basically we achieved that? Because we configured everything for the 5 regions, and that metadata was available, and quickly we can actually leverage that, reuse the whole metadata and replicated all the similar scenarios for the 65 regions. So that way actually it was possible. So everything is metadata driven behind the scenes. And for one of the UK customers where a lot of, it's a bank, large bank, so where we had to basically ingest data, a lot of streaming data, the real-time data, and they had about different formats, and almost it's about 9,000 different sources that we had to basically ingest into the big data platform. So we could actually do it that, because everything was actually templatized, and with all the ingestion mechanisms that we had, so we could actually do that. Also, it's not only on-premise, but also it basically works on the cloud environment, Amazon and Azure. So as I was mentioning earlier, so this is the fuel engine from the data ingestion perspective for our other product, that is data discovery platform. So in those cases, for an healthcare customer, basically we were able to do that, all that the required data ingestion, the processing power, basically we could provide with BDRE to that. So in summary, as I was mentioning, so a lot of things still the community is actually contributing, and even Wipro also basically investing a lot of effort in making this more robust. So for example, we integrate with Spark ML. I mean, not only from the various data sources that we are talking about, also from the processing perspective, and I also mentioned about the data discovery aspect, and other part is also integrated with Atlas. So if you look at most of the big data initiatives, the metadata management, these frameworks is fine, but end of the day, data governance is going to be very key. So you will take care of the data quality part of it, but there should be a governance process.